Hello, my name is Daniel Scheifler. I'm principal consultant here with Improving, and I'll be your host today. With me is Michael Slater, a technical director for Improving and head of Improving AI, and he'll be helping us to explore the challenges and opportunities that come with building AI-powered applications during this podcast-style interview. Michael, say a few words if you would.
Yeah, thank you, Daniel. Technical director of AI for Improving here in Houston. I'll say my background is primarily in building large software products and systems. I've done everything from business intelligence systems and supply chain. I've built the back end of video games and network design. I've shipped tons of enterprise apps for internal users and consumers. And along that way, I went back to school and got myself some AI learning. And I'd say what I focus on most is shipping AI products, right? There's people in AI who live on the research frontier. I have a lot of respect for those brainiacs, but what I like to focus on and what Improving does for our customers is we build and ship AI products that we want to be able to use today. So a large part of my focus in the AI industry is on, kind of like what we can do in the current, development period, like what can be started development today and shipped, in weeks and months, you name it. And so I
Right.
focus a lot on the AI product engineering there.
All right. Well, I mean, that sets us up basically perfectly for today's conversation, where we're hoping to apply those software engineering insights you've got to these AI type problems. But let's start with the business case, right? Everyone starts with, oh, it'd be cool if we could. How do I know when my business case is actually suitable for some variant of build your own AI?
It's really easy to take your product and go, hey, we should just have some generated AI output in here. I'm sure our users would love that. And I can tell you firsthand, I'm sure your users won't love it.
Yeah, it
I
sounds
would
about right.
I would say, like any endeavor, you should go through a process of, right, researching your business case, your users, ask them if they'd actually appreciate this feature, and understand that you shouldn't build something that just attaches like a large language model output and call it a day, right? You should
Hmm.
have some kind of unique case, like either with your users' data, maybe with the expert data in your system, where you're using a combination of proprietary data or hard to get data in unique and novel ways with the augmentation of not only large language models, but traditional AI to give, novel outputs that are really beneficial for users.
Hold on. Can you go back just a moment? You mentioned this traditional AI, which is a
I know.
fun little thing there. What do you mean by traditional AI?
That's a great question. And, AI has been around, you could say, since the 80s, right?
All
Like the
right.
mathematics involved were developed way back then. Or you could even argue before that, but really, became more apparent then with the age of computing.
Hmm.
Because traditional AI is a large amount of statistics, mathematical equations. Like you hear things like Bayesian's theory,
Right.
right? So I call now what used to be just machine learning and AI before really the craze of large language models and other generative AI systems in general. I call that traditional AI, and that's when you're using these more statistics-based approaches. Think
Okay.
like price prediction, stock market prediction, like where you're predicting numbers
Hmm.
from data sets using those, more traditional statistical machine learning training. And that AI is actually as relevant today as it's ever been, right? It just now we have this other way to interface with AI systems through language models, image generation, things that are really exciting to users who aren't always thinking in terms of numbers,
All
right?
right.
But those AI systems and models are still behind the scenes deriving experiences that we may even assume as consumers, oh, that must be like Chat GPT. Well, it's like, no, behind the scenes that it looks like that person's hooked up a math function. So I would call that
Yeah.
traditional AI.
All right. So you mentioned that in addition to thinking through whether we should just be using the traditional AI with the data I likely already have in hand to make a really convincing case for build my own AI, that I ought to be looking at more than just, slap AI on it or directly give the output there. It sounds like maybe I should be doing a little bit of industry research to see, A, has this been done before rather than just going off and inventing the wheel myself? Is that kind of the thinking you've got there?
Yeah, because when ChatGPT came out, we had the first wave of AI startups,
Hmm.
and a lot of them centered around even changing the system prompt of the language model, slapping together a cooler chat interface, and calling it a day, right? But as we've looked at things like custom GPTs come out,
Uh-huh.
function calling, like I'd say over half of the first wave of AI product ideas were kind of made obsolete by the AI models themselves as they just natively gained those capabilities. So if
Hmm.
you don't want to be swept away by just the next model update or the next interface update from, Google, OpenAI, Microsoft to their Copilot, ChatGPT, name your product. If you don't want to
Hmm.
be swept away from that, you need to integrate AI in your product in a way that's very unique and novel to what you're offering. And it needs to go much further beyond just the capability of a large language model, right? So that's usually in the case to start with, like the easy stuff of a unique way to combine your internal data, whether it's from users or from, innate to your system
Hmm.
with AI, because it's using that data to do something special, right?
All right.
And if you're not hitting that minimum bar, and because that to me, that's where use cases start, right? And that's
Hmm.
not, they go so far from there. If you're not hitting that minimum bar, you're going to struggle to just stay ahead of what the standard tooling of the industry is going to be putting out every few months.
All right. So if we're talking about the emergence then of an entire new tool chain, it sounds like we might be talking about adding a new specialty to the team that I might be considering to run. Is that really the direction I need to go with this, or is it something I can kind of handle with what I've got?
It is. No, I think teams do need to add a specialty. I mean, this is like when what's a good comparison is like when we finally decided to add UX, user experience, as a discipline
Right,
to
right.
software engineering teams. Like, I mean, what you remember the early interfaces of the 2000s? Let's put Excel into the web browser. You know how many times I heard that?
Yep, terrible ideas.
And so we had just developers building, UIs, but really without thinking like how the UI would be interacted with, if it was intuitive. And eventually we had a whole discipline around that. And so, in the early days of AI, you'd have some model developers make a prediction model, but more or less it takes an input, spits out an output. It's very controlled environment, like it's
Right.
a number. Um, and so like that didn't really fundamentally change the way you organize the disciplines of your team. I mean, like academic disciplines. But let's call it with large language models, we're building these agentic systems or like business agents, AI workflows. There's a couple terms for them out there.
Hmm.
And you're going to be using like technology frameworks like LangGraph, Crew AI. There's a bunch out there. I can't even begin to name them all, and not only is that probably some kind of machine learning engineer who's choosing to specialize in generative AI, they need to really understand how to build these workflows in a way to invoke large language models in combination with the data and controlled prompts in a way that
Hmm.
is unique, but also has to be done in a disciplined manner, like any software system is done.
Okay. So you kind of mentioned UX kind of growing up in there, and obviously there's the need to learn to interact with this system well, learn to need to build it well. But does he, in your experience, actually change the way we need to build these systems to begin with? After all, you mentioned Excel for the web. That was just us dropping tables everywhere. It sounds like you're suggesting maybe we need something a little more finesse than just slapping ChatGPT on the chat along the side.
Yeah, and part of it is like let's say you want, and let's start with something easy, right? You
Hmm.
want a chatbot experience as a piece of your main web app. It's not going to
Sure.
take everything over. And so you may just decide, oh, I can just add a machine learning engineer to my Scrum team. They're going to make some kind of artifact that just like I send a message to and it sends a message back.
Right. Another
And
API call.
yeah, and presto, it's going to work. I would challenge that quite a bit.
Uh oh.
Um, because right, it's not a mature discipline to create these AI agents, right?
All
And
right.
everyone doing it and putting out software fast, they are doing, and I talked to a lot of these people, and I'm doing it myself today on a few different teams. we're kind of doing the R&D in parallel to the software development, right? But
Oh,
we're doing that because we're trying to, stay up with the craze. But we really don't have like a large amount of standards of this is how AI agents should be built. This is how they
hmm.
should be tested. This is how you measure quality. I mean, name all of these standard concerns you would have as a systems architect, Daniel, or a product manager.
Right, right.
And majority of those don't really exist, and they are different.
Hmm.
I wouldn't say that they fall in line one to one with standard software design. I would say that all of the bullet points kind of like you need to concern these things, but the way you concern them actually becomes kind of novel to building AI systems. And I would say all of that starts with the basic fact that AI outputs are not fully deterministic, right? And so
Right.
everything falls under some consequence of that basic fact of an AI system versus software systems where like it's either going to give a successful output or it's going to throw an error, right?
Right. It's
And
either A, it succeeded, or B, it failed. With these non-deterministics, are you telling me it's going to be like a kind of?
yeah,
Oh
yeah, it
no.
will be a kind of. And so you should apply that mentality like to every aspect of the software engineering discipline. Like, how do I change error handling
Hmm.
when it's not deterministic? How do I change API design when I know it may not be deterministic? Because you're not going to just throw success and errors. You're going to maybe indicate quality of response. You're going to maybe indicate when or when not a response should be used, or indicate, hey, maybe suggest this to the user instead of applying it. Right? You
And
start
that suggests then
thinking
like a new user experience then.
it does. And because, I mean, if you've used Cursor or Windsurf or any of
Yeah.
the AI agents, this is like the first example people are really getting of truly agentic AIs, right? Like it is still mostly a chat experience in a way,
Yeah.
but like you ask a question to these development environments. These are tools that software engineers are using, of course, and it sort of starts talking about what it's doing and doing it. And the
Hmm.
experience it gives you, think about how it makes you feel. Oh, it sounds smart. That's what I would have done. I mean, that's what I'm thinking as it
Yep.
goes.
No, I know exactly that
Sure,
little internal monologue.
surely I would have thought of it, so it's not replacing me yet.
Yet.
And but like it's making you comfortable and it's asking you your permission when it may be doing something potentially like destructive, like running a terminal command, you
Right.
know? And it
Trust the human, keep
shows
them
you
in the loop.
keep the human in the loop. I promise I'm not like reading all your files on your computer and sending
I
them out to
promise
the
I'm not
web.
Skynet.
Yeah, and so
Ugh.
it's asking for your trust and your permission. Like, so I'm talking in experience language. It's keeping you informed
Hmm.
and showing you on the screen the actions it's taking. If you think of like the tab complete, we're very used to the UX on that, but we're very used to tab completes that are pretty much always correct. Like it's suggesting something that will be compilable
Right.
to start with. Now it's tab complete. It's like it'll tab a whole function and be like, hey, like you called the function, multiply numbers or whatever. I'm gonna actually do that for you. It's like that's pretty novel. And now you're not just thinking, oh, well, will the tab completion compile? You're like, well, is it even right?
Yeah. Is
And
it
so
trying to
these
do a bit shift operation rather than multiplication?
yeah. And so the user experience of building an agentic AI, you have to realize you have to build trust with your users. You have to keep them informed in the loop. You don't want to do things that are so magical that they go, "How did you do it?" Because
Right.
in a way, it may be amazing in the short term, but you lose confidence, I think, in the long term. So I try to tell people who's like, "Hey, I want to build this agentic experience." Part of my first concern is, hey, how are you going to do this so users trust your AI, that they trust the outputs?
Hmm.
Because quality will be a sliding scale, right? And you're going to have some bad quality. So how do you maintain trust when that happens?
Okay.
Right. And we've all had bad quality outputs from, Cursor or Windsurf or whatever, or ask ChatGPT a code question and you look at it and go, yeah, that's Python 2. Please rewrite this in Python 3.12. Like you done that yet?
Yeah, no, I've had that. And it's so, what's wrong with your head? Like I told you that in the prompt.
Yeah.
Half the time I'll admit it's like user error. I gave it a bad prompt. But like there are just some things that baffle the mind. So it sounds like designing a trustworthy experience where the end user, not just the developer, feels confident in engaging with this new AI feature is going to be a critical
Yeah.
and hard discipline to master. In your experience, since you said you've released several of these production, like what are some other hard things that most people wouldn't expect at the outset of their project?
Yeah, so I would say like, so we've learned of this tool called, or technique, it's not a tool. It's a
Mm,
technique called retrieval augmented generation. I mean,
right,
it's
RAG.
the easy rag, it's the easiest thing to talk about. It's fairly explainable. But you know what's really interesting? People go, you just turn your text into vectors, and there's this hand waving that sort of happened. Vectors, vectors. And all of a sudden, AI searches and finds exactly what you look for. And every time I hear it, I just imagine this like magician waving his hand.
Yeah, yeah, it sounds about right.
And
Highly untrustworthy language there.
and we're all trying to elevate the language in a way where we're trying to make these promises like, yeah, these vectors, they just work. They of course return the best ranked search results. And yeah,
Doesn't that
like
all
you just
depend upon your
integrate it.
embeddings?
And so if we start at the basics, right, what
Right.
embeddings algorithm did you use? Is that algorithm correct for the exact way you want to search? Because, like these are like sentence similarity algorithms is another
Mm-hmm.
phrase for them. And some of them use different techniques. Like some are better for long form text versus short form like tags or topics.
Right.
Some are better than others at eliminating filler words, right? And so you should know your content and realize, oh, is this embeddings algorithm good for this use case? Then you may need, you've even heard vector size. And vectors are really big, by the way. Like they'll add gigabytes to your database before you know it.
Mm-hmm.
And so like, are you just going to use the largest size vector, right? What's that going to do to your costs? What's that going to do to your speed, your data size? You don't really worry about the cost of computing vectors. It's still pretty cheap compared to like
Mm-hmm.
regular large language outputs. But actually, so like every one of these concepts that you hear, hey, just do RAG, there's like I want people to understand there's so much hand waving that's done in that phrase, even from the AI experts. They know behind the scenes, oh, like a lot of these things will just work fine out of the box mostly. But like once you
Mostly.
start tuning those edge cases, once you start have users going, hey, it didn't return the search results I really expected. And like you start realizing, oh, okay, I just used OpenAI's large embedding model. I used the highest vector size, and now they're saying they're not getting the right results. I thought I used the best, and I threw it in Pinecone. And shouldn't it just work?
Uh-oh.
And so I say, hey, like, yeah, you got your MVP out we're talking about the most basic technique that people have been talking about for 3 years already. And
Mm-hmm.
now how do you actually make it good? And so I would say, I almost forgot what the original question is, but I would say like every one of those hand wavy things, like just do this in your AI app, there's going to be, hey, you can prototype that, you can ship it, but the feedback will come.
That didn't sound ominous at all. All right. So speaking of feedback, right? We're talking about adding an entirely new discipline to a dev team. Let's go back to that topic, right? Like, so I'm a software dev. My first concern is obviously with my software dev team. What's the stuff I need to know? Like, what's one thing I have to know now that I'm adding a new discipline and I'm about to start this build your own AI project?
Yeah. So let's start with the title machine learning engineer or
Okay.
AI developer. And these people come from two backgrounds in my experience, and both produce great engineers. It's all about how you onboard them and build your product, though, and knowing what you have and who you have and what their strengths and weaknesses are.
All right.
And
So
I say
know my
that
people.
because, yeah, know your people. So on one camp, and I'll start with the easier camp, you take a software engineer who had a computer science degree. That's what I have, right?
Mm-hmm.
And I built some enterprise apps before the AI craze. So like I know how to build systems, I know how to ship to the cloud. I know how to build APIs and design them and do RESTful or other types of schematics. And so I had to learn AI. And then I don't think though maybe about all those advanced techniques. I just kind of do what the tutorials tell me and my AI is so-so.
Okay.
The other class of developer is you have this person who came from a math-based background. And these are people who maybe got a data science specific degree, a mathematics degree. Actually, I have a surprising amount of people who work at Improving who have physics degrees who are machine learning engineers. And if you think about it, it makes a lot of sense. A physicist applies mathematics by nature, which actually is what most AI is. It's applied math. So like they naturally think in AI terms pretty well. But think about what those engineers don't have. You may have someone be like, oh, this person created the most advanced ML model I've ever seen. And then you go, hey, like, can you throw me an app that returns this in and send me the JSON schema? And they may go, well, what's a JSON schema?
Yep, no computer science background.
No, or they just haven't shipped a product, or they don't understand a lot of these terms that we take for granted, right? And that doesn't make them like any less engineer or more engineer. Just it may though change how you organize your team. And so let's say you have a machine learning application or a product that's going to have machine learning. And let's say you've made a standard decision, like it's going to be a Python app that returns JSON APIs, kind of like any other deployable app. So does that machine learning engineer know how to build an API? You know they're a great machine learning engineer. So ask the question, right? Do they know like something we take for granted now in the Java, C# type land? Have they ever like made sure that the Swagger page gets configured? That's a very tactical thing, but it makes a huge difference in the way that dev teams communicate, right? Like backend engineers and front engineers don't have to talk a lot because they're like, yeah, it's on the Swagger page. You know,
and as long as the Swagger page works, I can get what I need.
Yeah, and it speaks for itself, right? The communication patterns. And like we take for granted that for like a decade, it just pops in most of our frameworks and it just works out of the box. Not only is it not out of the box in most Python frameworks, except Fast API, which I'm going to give a strong opinion, just use Fast API for now, because it automatically generates that Swagger page. In Python, you know, types are optional.
Right. It's a duck typing language.
It's a duck typing language. So if you don't actually return that type from that API method in Fast API, it don't know what it is. The Swagger will be like, yeah, it accepts text. Crickets, you know, and so like do make sure that all these standard concerns are known things in your team members, right? And so I say like team leads of an AI focused product, they should still be a person who has shipped software, more so than a person who has built AI agents or models. And maybe you have a dual leads system, like you have a lead for the mini R&D cycles going on the AI side. Then you have someone who really knows how to ship software because, and I've made this mistake myself. If you make these assumptions that the ML engineers know how to build great APIs, take away the AI, just build great API apps and know how to deploy them to, you know, a server, a Lambda, you know, functionless, serverless, whatever your deployable is, a Kubernetes pod. Don't take any of that for granted if they have that knowledge or not. Do they know how to build right API apps? Should be the first thing you really ask your team members when you're going to build a machine learning based component like a large language model integration.
Right. So if I have to essentially take the basics of software design as they're no longer granted, I probably need to scaffold and help them out with that. What about estimations? Should I be reconsidering whether I'm going to even be like, don't get me wrong, software estimations are already a dime a dozen, good luck. But like, it sounds like you just mentioned like that special word, R&D cycles.
Yeah.
Well, what's that do to my estimation planning that I have to do for the business?
I'll give you an example. You have a UI and not only is it going to spit out some chat on the chat box, but like you want the AI to response to do a thing, like change the state of a widget on the screen. And innately, a UI developer knows I need a well-structured payload that tells me exactly the data in the right schema so I can detect that I get that piece of data and change the widget.
Right.
The large language model developer, if they haven't really built an app before, is like, well, no, I'm sending you streaming text
Oh
And
no.
sometimes sometimes the JSON's not valid. I mean, that's your problem, right? Wrong.
Nope.
And so consider that like um you may need to set standards up front. Like a standard on my team is almost all LLM calls
Hmm.
are done with a structured output. And for, if you've been doing some AI development, that means actually you don't get free form text back. You give it as an expectation to the model call. This is the JSON format you're going to give me and nothing else.
All
Right.
right.
And in a way, and I mean, we're going to get so technical in some of this, like the structured output is almost a self-documenting prompt because the name of the output is going to invoke some like intelligence in the language model. And so you have to start really thinking about all things. So if you go back to estimates when I just mentioned this, if the team hasn't already like prototyped that kind of widget working that the AI developer has built one before
Right.
and they've deployed it, and if you're like in the same sprint, let's assume we're doing like some weird or same Kanban item or whatever. If you're going to both build the endpoint that does that and ask the UI developer to build the widget, and you expect that to be your deliverable at the end of the effort, you're going to have a bad time.
All right.
I
So
imagine
how do I
like
deal with that? What's your recommendation?
my recommendation is the first thing you should do when you have AI outputs is very stringently try to agree on the API contract,
Okay.
right? And so force the machine learning engineer and just the other developer to agree on a response request and response schema. Maybe it changes a little in the process, but like fundamentally, you should have high agreement and much more so than you're used to like in a standard backend API. We make so much assumptions about how backend APIs have looked. We've done it for like 15 years in our industry now.
Hmm.
We take a lot of like we just know how APIs are going to look when we talk about them vaguely. So a lot of teams
Yeah.
don't talk about them in detail. It is not that clear, like, and when a response comes back, that's going to be mostly generated by a large language model, what that is going to look like. So you should have a much more deliberate approach to designing your input and output contract, much more deliberate than you're used to.
All
I mean, it
right.
may feel weird as a dev team to do it, but if you don't do it, you'll notice like, oh, well, like it works better if the output was this way or that, and
Right. The
just
ML
trust
engineers
me.
are making changes that work for them, and the front
Yeah.
engineers are asking for changes that work for them, and we're not agreeing that this is the way.
So I would say agree on your contracts, agree on your response time. So like I've
Okay.
had product managers that go, "Hey, they're going to put in these things. Behind the scenes I'm doing a RAG. I'm running like a couple function calls, a bunch of database inputs. I'm like if you think of an agentic AI,
Hmm.
like the idea is an agent, let's say in like a four-step process or something, the user queries. Cool. That query does a RAG. And a RAG, though, may include several invocations, like it may do a prompt expansion. It does a couple queries, it ranks, it does a relevance invocation on the LLM to make sure, hey, only filter this for relevant documents.
Hmm.
Then it does the actual invocation of the query with combination, right? Your RAG. And then it does a response. How fast do you want that? Do you expect that to happen?
I think it depends a lot on how big that vector I picked at the beginning might end up being.
Well, and that's where I got to, the earlier part, like, hey, I'm just going to use the largest vector
Oh
possible.
man. Oh
And like,
man.
oh, actually, that had a significant consequence. Like, if you threw that in a standard database, that could take a few seconds. And a few seconds in user experience land, I mean, if you even utter the word second, most users are pissed off,
Yep.
right?
And
And
then there's like
so
a whole design you have to make of like, I'm working on your answer.
yeah. And so like in one of my early products, like I was like, yeah, 25 seconds, we got a good response. That was not acceptable.
No, I was gonna say no user on the
And
planet's willing to wait that long anymore.
so the next thing is like you have input and output contracts. You go, hey, between on the user's experience of each interaction, what response times are we seeking to achieve? And you have to balance the what the product manager wants to do with what is truly feasible from a speed um, possibility.
Okay.
And they may ask for a speed that is possible, but with advanced caching techniques, with the fastest of all vector search databases, with a smaller
The
model.
most expensive.
Right. Well, actually, a cheaper model because it has less parameters
Oh,
and
yeah,
it
yeah, yeah.
goes faster. But then you may get lower quality. And so I would say the next big thing, any agentic workflow, what is the response time expectation of the experience we're designing?
All right.
Right. And you may do tricks. Like you may have it, hey, quickly output what you think you're going to do before you do it. That way the user starts reading, but then you're still like computing.
Still figuring it out.
And
Okay.
so response time expectation is really big to know up front, right? Because
Okay.
it'll change your whole user experience plan if your ML engineer is like, look, I really can't get you a response faster than 20 seconds. You go, okay, how do I design an experience where the user's still happy with that kind of time? It's probably no longer like a chat experience. It's probably some other kind of mechanism where they expect it to like a notification, something else happen. And so I would
Some
say
asynchronous flow.
upfront, really decide on the response time. It does contract and time.
Contract and time. All right. So we've dived nice and deep on the dev team piece. We're about halfway through our time, so I want to take a minute to check our audience to see if we've got some questions flowing in there. Armando,
Thank
can you
you.
help me out?
Thank you, my friend. We do have a couple of questions for our experts. The first one says, from Gabriel Morales, is there a way to start experimenting with RAG, fine-tuning, and other AI tools without spending a lot of money and avoiding making mistakes in a client project?
Yeah, I would say like so if you want to experiment, you can do almost everything locally, right? Like you can have, Pinecone, Weaviate, a couple of those open source database running like on Docker on your local computer. You may want a beefier than usual development computer for the things I'm about to suggest, but so you can get your vector database locally. Of course, we all know how to have a local dev database. And in embeddings models, there's actually models out there if you're just learning that can run on C that are like CPU optimized. And so you can pull those down from Hugging Face, run that in a container. And if you do like, let's say like Olama locally, like most people can run a 7B model on their development machine, right? 7 billion parameter model. And so like you can get Llama or a couple other models, right? And you're not worried about quality at this moment. You're just learning how to do the activities, right? Like you're learning how do I make the vector? How do I put it in the vector database? How do I query it? How do I combine it with a prompt? How do I do a structured output? And so you can do almost all of this like more or less on your local machine for free. And that's the best way to not spend any money. I would say like one thing that's underrated though is if you've ever heard of, and I'm going to say Grok with a Q, GROQ, not the other thing. That is a fairly cheap inference platform that you can get an API key. One, you can do a bunch of free requests. Of course, don't send sensitive data on the free tier. But the API, like you can spend only a couple dollars and do a significant amount of calls on the 70 billion parameter Llama model or the DeepSeek or whatever the DeepSeek hosted in their servers, not in China. Um,
Be very careful of
user
that.
be aware, right? And so that if you're willing to spend a few dollars, you can get a much higher quality model for cheaper, right? And by the way, you'll get spoiled by Grok, so be warned. It's faster than almost everything else out there. But and then you can same with they have some vector algorithm embeddings algorithms on there, and so you can up your game with a couple dollars. So I would say that's the cheapest way to get started for free, right? Start on your local machine with Olama, some Docker containers. You can move up to something like Grok and get some super cheap inference.
I started the conversation by saying, let's assume we're developers talking about adding a new skill set. Let's kind of reverse the script on that a little bit, right? Suppose we're talking to like ML engineers. What's the one thing they need to know before they're attempting to productionize some AI app or project by working with a Scrum team?
Yeah. And I'm going to say answer this from the perspective of an ML engineer who has not shipped traditional software before,
Sounds
right?
good.
Because if they have, they'll know a lot of these things. But so the first thing I'll say is, look, you should know how the system is going to communicate with your AI. So, and I say that because it's easy to make assumptions. It's like I started this conversation with assumption that you're going to build a Python app that returns HTTP JSON. That is like a very loaded assumption, right? I mean, you have like different protocol, like you have gRPC, you
Mhm.
have protocol buffers if you need a payload minification. You've got you may not be targeting Python even, right? And you don't need to target Python, but know what you're losing if you don't. And so you need to know those things early, right? Because it with the amount of volume and that, like if you don't know how to measure throughput of volume, just talk to architects, design systems designers who have shipped systems before, be like, hey, like how many requests per second and is my system supposed to handle? Right? And that right, if you've built a lot of apps before, that's a pretty standard question. If you haven't shipped a lot of apps, you don't really think about the nature of like, oh, like every AI agent takes, let's say, 10 seconds to respond, but I'm expecting 100 requests per second, 1,000 requests per second. So then you think, well, how does it scale? Are we hosting this on a scalable system? And then there's education to the other side where you go, hey, like I really need to build this in Python, right? So it's a slower language than maybe the other part of the apps, which could be in like Java or C Sharp or Rust or
Mhm.
whatever. So it's a slower language. It has different consequences of handling asynchronous TCP connections. So you usually scale a lot more pods than you would in maybe standard software services. But then, like, is it stateless or was I expecting to keep some data in memory? Something API developers have thought about for a long time, and we have
Right.
massive learnings and systems that deal with stateful versus stateless apps. That may not even be a thought in someone who's like, oh, I always keep a couple things in memory because I run it on my machine and it works.
All right, so this is like the second or third time you've come back to that same thing where like someone needs to think about frankly the software design side of these things, the software architecture or
Yeah.
something. So it raises that very obvious question. Hey, should the ML, the machine learning guy, learn to do dev, or should the devs learn to go do machine learning? You mentioned that, like, for
Um,
example, the computer science background could be useful, but it leaves you with a gap. What's your thoughts?
I, I think first, I think everyone should always be able to learn more, though I know that's
Okay.
not always realistic. So
Yeah.
if your ML engineer comes from an ML only background, I would pair them. Like I would not design your team where they're alone developing their artifact. Give
All right.
them a standard software engineer, right? Um, who has at least built an app in that language, like Python, and have them work together on a team building all these concerns. That they have someone to review their pull requests. They have someone to offer suggestions, right? And of course, everyone should try to work on all aspects. Like you may not want to silo them in the ML only side of it,
Mhm.
but they are going to focus there more. I mean, we know what naturally happens when people work together; they lean on their strengths. So I would pair them. One of the mistakes I made was throwing an ML engineer like, hey, make this Python app, and I just like, yeah, they're gonna figure all these things out. I'll review their PRs occasionally, and what I learned is like, oh, if we do peer review, people who don't know Python will kind of rubber stamp approve. I know
Mm.
Python, so when I looked at a couple of them after they shipped, I was like, ooh,
That's not good.
like that's gonna be hard to maintain. And so we go back and we rework. So I would say if you do more correct up front of deciding API contracts, of knowing that you can estimate things correctly, R&D, having an R&D cycle before you commit to a product deliverable, right? Know what the
Mhm.
quality, timing, contracts will be before you make your commitments and things like that.
So you mentioned quality a couple of times, and I realized when we were up with the devs, we didn't actually talk about how am I going to vet
Yeah.
this AI output. Now seems a good time, right? Like testing as a software concern, normal, standard part of the process. What's that look like for build your own AI?
Yeah, I mean, we're taught as developers to unit test, integration
Hmm.
test, functional test. I get tired of all the types of tests, but it's no joke when it comes to AI systems. Like one, yeah, you should still have some kind of unit integration testing
Hmm.
um for the systems and like logic level stuff in your code. But it is a whole different type of testing. Um when you want to test the quality of AI outputs.
Right.
And I'll give some pointed opinions just on what I've done that works for me. I don't get referral bonuses here, but like
Hey, good to know.
like I'm using right now LangGraph to build AI agents because I pay for Langsmith, which is this AI observability platform,
Hmm.
and has like a built-in test suite capability. And I say that because like I can put in data sets into this tool. I have a pi test, like, the test framework. But instead of asserting things are true or false, I return like numbers 1 to 10 of what I deem quality. Now, some things, you may design it and Langsmith or other tools support this, like a human review, and you give it a grade
Hmm.
of an output. Let's say just like given a RAG, it doesn't invoke, it returns a response, and a human can grade it. Well, it's not going to be, sometimes it's like there is a threshold for right or wrong, but then it's like, well, how right? Are they going to be really pleased, the user pleased with the output, or are they going to be like, oh, that was okay,
Hmm.
like lukewarm? And
And is
so,
okay enough.
and is okay enough for what you're trying to promise and sell. And then you may go, oh, well, I have so much data, I can't human review everything. What's the next technique? Well, lo and behold, they call it LLM as a judge. So, given an AI output,
Hmm.
in lieu of a human reviewer, you can just invoke a large language model with, hey, here is the original query, here was the response, and here is the grading criteria, like a rubric. Give it a grade. And I actually do exactly that. I give it a rubric. Like
Okay.
it's a
Okay.
structured output. I mean, we'll talk about all the things we're building upon, and it'll be things like word choice, right? Quality of output. Using if you're building something that's highly referential to the RAG, how many back references can it generate? Like, and you'll give it a rubric, and you'll just kind of literally ask it, hey, grade yourself 1 to 10 on every one of these rubric
Wait, wait, wait,
criteria.
wait. Hold on, hold on. You just told
And
me to have an LLM grade itself. Is that not like having the
yeah,
student grade their own test?
absolutely. Yeah, it really is. And then you can even decide, do I use the same LLM that I did to invoke this? Do I use other LLMs to grade it? You can go crazy.
Right.
But it at least gives you some measure
Hmm.
and they're actually surprisingly good about this. I will say though, they're biased to like the extremities of rating. Like it's gonna rate a really low or really high. Like I rarely get like, oh, this is a 6 out of 10. I rarely get a lukewarm grade. So
Okay.
you have to kind of at least know how good it is at grading. And then so like if something grades it like an 8, I'm like an eight's low. I'm like it's a 9 or a 10 for this grader, and you kind of get a feel for like how it's grading, just like you
All
would any
right.
other grader. And yeah, like you can run it over a large data set. Ask
So a
it to
lot
grade
of
it.
different responses.
Yeah, a lot. And really what you're using it for is, yeah, you get a big picture understanding, but also just sort it by grades. And it at least gives you a ranked priority list of things that you should investigate as the ML engineer, right?
Okay.
And you'll see these anomalies, and you go, okay, like why did that not anomaly occur? Did it not return the proper results in my RAG in the retrieval step? Did it did it occur because it did get the results, but then there wasn't applicable data, and so it kind of just hallucinated? Did it, and you'll ask
Yeah.
yourselves these questions, and then you go, what do I want to do about it? Do I want, and you start realizing, oh, I should build into my agentic workflow, and now we'll get really crazy. Every workflow should rate its own how good it believes the responses are to the query.
Hmm.
It should know how applicable it thinks the answer is to the question, the results, and things. And it can even give as part of your workflow these checks and balances, so to speak. And when that all returns to the system can actually decide how aggressively to use those outputs or at
All
all,
right.
right? And so you like your contract with the calling system can be like, hey, like you can check the rankings on certain things and even decide to give a different user experience based off my own rankings. And actually, we already do this early in the AI lifecycle when we had these safety APIs, like rate the response for violence or bad, kind of like those extremity
Yeah.
responses.
The
So we're actually,
censorship AIs.
yeah, we're actually already used to the concept of the safety API. This is like that, but call it the quality API or the quality
All
check.
right.
And again, like this isn't going to happen in your MVP. This is going to happen through rounds of feedback and testing and users going, "Hey, this isn't good enough." And you're like, "Okay, how do we in a disciplined manner make this system better?"
So speaking of discipline, a thing you've alluded to several times is the management of artifacts. This for software developers is like things like the API version. So I know I'm calling version 1 and it supports that. Version 2 supports this other thing. Are you talking about building up something similar for these AIs? Are we talking about managing the whole trained model, or are we talking about versioning the system for generating all of this?
Yeah, I'll say this is such a nightmare right now. Because like we're all used as developers to our artifacts, right? Everyone choose their artifacting strategy, versioning numbers, but we're also mostly used to, hey, we make PRs, those get versions, they get merged into trunk or main, those get a version, we release them. Maybe it has to go with some specific configuration set. That's like as hard as it gets most of the time.
Yeah, yeah.
But then more or less it goes out, and then anything else is like the ops people's problems, right? Or however you've designed your thing, right?
Yeah.
But now, like, sure, we still have that with, yeah, your deployed Python code, let's call it. But what about the actual prompts? Are those inline in the Python code? When you change a prompt, did you really change the code or did you change really what's configuration? And then like when you change the prompt or you upgraded your LLM model, did you change two things or one thing?
Computations. No.
So like you could go crazy and you could like I have like we're starting to use a prompt versioning system and treat it like a form of configuration.
All right.
And I go, hey, this prompt works well with this version of the workflow that is using this LLM model at the moment. And this particular structured output, which kind of is its own part of the prompt, but may not be like the system prompt. But it has a drastic effect on output.
So you're talking about like 4 different things that all need to be tracked.
So all of a sudden, like when you're trying to get really disciplined about building a high quality AI system, you go from like what was traditionally like a single software artifact with maybe some attached config options to a really complex, multiple moving parts, hard to have single control. Like if you experiment traditionally in science, you're like, oh, I need like,
just
control factors and change one. Like, but all of a sudden there's a lot of moving parts. Right, because when you're changing the code, then you update the prompt. Then all of a sudden, OpenAI releases GPT 4.1. And you change 5 things at once. What did you just version, right? And so I would say that start off, of course, at the minimum, which I think is versioning your actual build. But you're going to want to start thinking about your strategy for managing your prompts, versioning them. Test your prompts independently of even the whole LLM system. Test them against different model versions. Like actually, you could upgrade models and have a regression. And I say that because on one thing where we were using OpenAI from 4.0 to 4.1, I can give a really specific example. It actually got worse at having the instructions at the end versus the beginning of the whole prompt.
It got worse?
Yeah. So like, but if you flipped it, it got better. So think like LLMs, like a lot of people who work with them know, oh, for this LLM, I put the instruction or the query first, then the context information, like from the RAG. And that is the best order for this LLM. And other LLMs, it's the other way. But sometimes, even in a version update, that can flip for the same model from a new version. Right?
Interesting. So now we're talking even the structure of the prompt has to be versioned.
Yeah. And in like 4.1, I found that prompts that were kind of vague that worked really well, all of a sudden didn't work really well and had to get really specific, which actually is a good thing. I was happy with the change, but I had to go change all my prompts. And it was kind of like a big update we wanted to do because it was a much faster response time. The tokens were less. It was going to significantly cut the spending. So it was like an immediate goal to, oh, upgrade the model, but it wasn't just like a upgrade the model. Like,
Yeah, it wasn't a flip the switch, it was work.
yeah, it was a lot of work and a lot of testing, and it's a good thing we had some test suites around to actually discover some of those issues, because I could have just like put it out in the wild, and
Nah,
my users would have told me real quick.
makes sense.
And
All right. So we've kind of come close to the end. We got about 10 minutes here left. I want to go to the audience for questions and then give you a chance to give us some parting thoughts on this.
Thank you, Daniel, Michael. And we have two more for you guys. The first one says from Luis Ruiz, how to deal with constant changes of LLM frameworks, such as frequent methods being deprecated by LangChain.
they're the worst. Actually, I won't badmouth anyone, but they are a challenging library when it comes to this. Yeah, so like one issue is with LangChain and LangGraph and Crew AI, Haystack, name them all. They're rapidly iterating and putting out these features that you always want to use and incorporate, right? And whether you're like in Python or you come from like .NET or Node, like we're so used to package updates having like this major or kind of like, major, middle, minor version stuff, Semver or whatever. And yeah, it's kind of the wild west of upgrades when it comes to any of these libraries, I would say. And so I would say like try not to use every feature of the framework just cause. And I say that as the worst offender of that. Like I am the worst offender to overusing frameworks and libraries. But I would exercise caution in these and try to think, how do I make my own constructs and use the framework really for what it's good for, but not try to overutilize its features? Because they may like put out something that is meant to help you, but it's like, well, it really doesn't save me a lot of code. I could have written that module itself, have more control over it. I would say sometimes err on the side of doing some of it yourself in your own code, especially if it's a very new feature of the framework, and try not to jump onto every new method so quickly. And like if you think of like if you look at Crew AI as an example, they have and it's really cool. I love what they've done. They have all this terminology for different ways to invoke your agent and when. All these concepts. It's a really good ontology. I like to use the word ontology now. But if you overuse it, and if you've been through the life cycle of lots of upgrades, there's been a lot of refactoring. Whereas if you had maybe underused it and used only what it's good for, it would have been less. So my only advice right now is try not to overutilize the framework. When you think you can write something comparatively well yourself, there's no reason to use the internal framework call for that. I would err on the side of doing it myself. Like LangGraph, the thing I love about LangGraph is its core feature. It manages a state of your workflow through a graph of nodes and edges. And it's like at the end, input and exit of every node, it has changed your state graph. You can have checkpoints, you can have those things. It's really good at that. It hasn't changed a lot in the core way it does it. There's some like little off the side functions that I use and then they're gone. And I do like when the AI frameworks make whole new modules to do things a different way. LangGraph did that with their latest update. Just be careful how fast you try to jump on it. So, I mean, that's the best advice I can give. Just be aware that, I mean, for at least for another year, these things are going to undergo rapid change. And part of it is acknowledge it's because they are also responding not only to the demand of what developers want the framework to do, but they're also responding to the capabilities of the models themselves. So like structured outputs were not in the original launch of any large language model, but the frameworks try to emulate them. And then the model developers go, oh, we can like do that in the model and do it more reliably. Well, now the frameworks how to account for the fact that structured outputs could be used abstractly, right? Depending on if the model supports or not. So then they abstract things that you may not actually need abstracted. Like if you're like I'm of the mindset I'm only using for these big agents right now models that support structured outputs natively. And so I'm not going to overuse abstractions that work for models that don't support it, because I'm like, no, I'm not ever going to switch to an LLM that doesn't use structured output. kind of compare this to like the repository pattern of databases. Well, what if I switch my database provider? Well, what if you don't? You know?
Yeah, that's a classic question.
Yeah. So I would say don't overuse the abstractions.
All right. So, Michael, we're down here to the last 5 minutes. There will be a couple more questions. We'll forward those to you afterwards for your wonderful answers. But I want to give you the chance to leave the audience with some quick parting advice of like, hey, you heard all of this. What are some good next steps?
One, I would go look at the content Crew AI and LangGraph. I follow their blogs and YouTubes a lot, as well as the deep learning stuff that come out. So if you want to stay on top of kind of the AI agent development, like those three entities are putting out a lot of high quality content. So for the AI agent side, I would follow that. If you're a ML engineer who comes from a non-software background, I mean non-software engineer background, so you come from like a more science or math based, go look up some courses, and this is a strong opinion, on object-oriented Python. And I know I'm going to get eviscerated for saying that out loud, but let me defend myself. Don't feel like you have to do Python in an object-oriented way, but what that course will naturally teach you, and I've done a few of them when I learned Python, they will teach you standard software design concepts that you would not otherwise get exposed to. Because you're not forced to use them in Python. Unlike other languages, you're kind of forced down this path, right? And so you'll learn things like inheritance, polymorphism, composition. You'll learn these abstract software design concepts that will help you in your journey in writing better code. You don't have to use them all, but the learning of them will make you a much better developer of Python code. And more aware of how other engineers in other languages develop software. And the difference is, like, if you think of C# or Java as an alternative, you are forced, like literally forced, to use these advanced design concepts in the language, because the language is like, this is how you do it, buddy. And in Python, that's just not the case. So you kind of have to force yourself to learn the language of other software design that other engineers kind of take for granted in learning in other languages. And again, take what works for you. Don't feel like you have to use everything you learn. And type your Python. Put types on everything. Type your Python. Please type your Python.
Save your software engineers some headache.
Don't return random dictionaries. Don't do it. Use Pydantic v2. Use the base class stuff. Sure, there's consequences you have to deal with, but those consequences are worth good types, good objects, classes. Again, use where it makes sense, but man, it is really hard going into a Python code base that doesn't have adequate typing. I'll tell you, it's a struggle bus.
All righty. Thank you very much, Michael, for sharing with us your expertise. I would like to turn the audience's attention briefly now to the next talk coming up in this How to Use AI Effectively series that we've been running during the month of June. And that is with our very own Arturo Mosquera. Love the guy, great speaker. Come see how he talks about the code we've forgotten and the impacts that'll have on your team and the developers, especially as we start using AI to generate more and more of that code.